Did you know it's possible to land on Venus without a parachute or even a rocket engine? This surprising fact was discovered by the Soviet Union over 50 years ago. After years of trial and error, their missions finally revealed the harsh but fascinating truth about the hottest and most mysterious planet in our solar system. This is what the Soviets uncovered when they touched down on Venus, and why, after these revelations, they never tried it again. Asterisk. Venera is the Russian word for Venus, and it's also the name of a bold series of 16 Soviet missions aimed at exploring Earth's closest planetary neighbor. From 1961 to 1985, the Venera program sent probes and satellites to map, study, and uncover the secrets of Venus. On the surface, the goal was scientific discovery, but there was no denying the political stakes. During the space race, each mission was also a demonstration of Soviet technological might and ambition. While Mars dominates modern headlines, in the early space age, Venus was the real prize. Mars was already understood to be largely barren telescopic observations, had ruled out the fantastical canal theories, and most researchers accepted it as a dead world. Venus, by contrast, was an enigma. Shrouded in thick, impenetrable clouds, its surface remained invisible to Earth-based observers. What lay beneath? The dense Venusian atmosphere suggested possibilities that Mars simply couldn't match. Could life exist there? With proximity to the Sun and a cloud layer acting as an insulating blanket, some imagined Venus as a tropical paradise, a prehistoric Earth teeming with alien flora and fauna. Yet most scientists were skeptical. Astronomer Carl Sagan had already proposed that Venus' perpetual cloud cover might indicate a runaway greenhouse effect, superheating the planet and creating a surface of scorched, uninhabitable terrain. To find out, someone had to go there. Enter the Soviets. In 1961, they launched Venera 1 and Venera 2, the first attempts at studying Venus up close. Launching missions in pairs was common practice. Engineers knew that early interplanetary flights were highly risky. With nothing but primitive computing power, rocket engines, and a lot of hope, the Soviets sent their probes atop an R-7 ballistic missile. Both missions flew within 100,000 kilometers of Venus, a remarkable feat for the era. Unfortunately, both probes suffered system failures before reaching the planet, returning no usable data. It wasn't until 1962 that the Americans achieved success. Mariner 2 flew within 35,000 kilometers of Venus, completing the first close-up observations of another planet. During a 42-minute flyby, it collected data on Venus' atmosphere and surface from both the day and night sides. The results confirmed Sagan's greenhouse theory. Venus was scorching hot. Far from the imagined tropical paradise. Asterisk. By the mid-1960s, NASA had largely abandoned Venus, deeming it too hostile for human or robotic exploration after Mariner 2 confirmed scorching temperatures of up to 237 degrees Celsius, 459 degrees Fahrenheit, and dense cloud layers stretching 56 to 80 kilometers above the surface. Focus shifted to the Moon and Mars, but the Soviets were undeterred. They doubled down, preparing a second wave of Venera probes, unaware just how brutal Venus would prove to be. In 1966, Venera 3 and 4 were built bigger and stronger, weighing over 2,000 pounds and equipped with barometers, radar altimeters, gas analyzers, thermometers, and detachable descent modules. The plan: deploy parachutes to drift through Venus' atmosphere and measure temperature, pressure, and composition all the way to the surface. Reality, however, had other plans. Venera 3 suffered a system failure en route, yet it still crashed into Venus, becoming the first human-made object to hit another planet, a historic, if unintended, milestone. The Soviets had now accidentally scored a hat trick, impacting the Moon, Venus, and Mars before actually landing successfully anywhere. Venera 4 in 1967 came closest to success. Its descent module deployed correctly and entered the Venusian atmosphere, collecting the first in situ measurements of another planet's atmosphere. At high altitudes, the conditions were surprisingly Earth-like temperatures and pressures comparable to a warm summer day. But as the probe descended, Venus' climate grew extreme. Pressure and temperature skyrocketed until, after 90 minutes, transmission ceased. The capsule had likely been crushed like a soda can by the dense atmosphere, a terrifying reminder that descending into Venus was akin to plunging into an ocean of air, so heavy it could obliterate metal. Undeterred, the Soviets launched Venera 5 and 6 in 1969. Both survived less than an hour, meeting the same crushing fate. Meanwhile, NASA's Mariner 5 flyby confirmed that conditions were even harsher than previously thought. For the next attempt, the Soviets got creative and ambitious. Venera 7 and 8 introduced major improvements. The descent module was reinforced with thicker metal, extra insulation, and a titanium internal sphere to protect instruments from heat, along with padding to absorb impact. They also engineered the parachute to partially delay deployment, reducing exposure to the hostile upper atmosphere until lower altitudes. Even then, success was not easy. On August 17, 1970, Venera 7's parachute only partially held, and the module plummeted to the surface at 61 kilometers per hour, bouncing off the ground. Yet every failure taught the engineers more about surviving Venus' extreme environment, a harsh planet that would eventually yield its secrets. One daring probe at a time. Asterisk when Venera 7 finally reached Venus in 1970. Observers on Earth assumed it had failed. Its antenna was damaged after all. Yet the lander was still transmitting data. And what it revealed was terrifying. The surface temperature measured 475 degrees Celsius, about 900 degrees Fahrenheit, hot enough to melt lead and far beyond what any machine could reliably endure. Undeterred, the Soviets launched Venera 8 in 1972. Miraculously, this mission succeeded. Its descent module touched down softly, instruments intact, and recorded for just under an hour. By now, it was clear that Venus was extreme. Temperatures above 475 degrees Celsius. Surface pressure 92 times that of Earth, equivalent to being 1 kilometer underwater. And an atmosphere filled with sulfuric acid, like a planet-wide battery. Yet, the Soviet engineers pressed on, determined to learn all they could. The next leap came with Venera 9 and 10 in 1975. These missions introduced a revolutionary design. The descent capsule now weighed nearly 5 metric tons, and engineers implemented a landing system that required no parachute for the final touchdown. Venus' incredibly dense atmosphere acts more like a liquid than air, so the lander could essentially free fall safely from 47 kilometers above the surface, its weird hat shock absorber slowing it for impact. A small parachute was still used higher up to reduce speed to subsonic levels. Venera 9 returned the first ever photograph from the Venusian surface. Jagged rocks scattered across a barren, sandy plain. Venera 10 followed days later, showing a smoother terrain likely an ancient lava flow. Venera 11 and 12 were less successful. Lens cap failures prevented any usable images, highlighting the difficulty of protecting instruments from Venus heat during descent. But the Soviets didn't give up. In 1981, Venera 13 and 14 marked a breakthrough. These missions captured the first color photographs of Venus, revealing flat, sandy plains with hints of cliffs or hilltops in the distance, giving a tangible sense of alien terrain. The landers also conducted soil analysis, discovering materials similar to solidified volcanic ash, tough, barren, and lifeless. Venera 13 even carried a microphone, capturing the eerie sound of Venus wind and the probe's operations. The design of the landers evolved with each mission. Metal teeth on the impact rings reduced spin and oscillation during landing, while reinforced shells and insulation allowed instruments to survive Venus Inferno-like conditions. These missions were not just technological triumphs. They were daring experiments in surviving one of the most extreme environments in the solar system. Asterisk. The soil analyzed by Venera landers was found to be very similar to basalt, a volcanic rock that forms much of the Earth's ocean floor. And that marked the last time a man-made object reached the surface of Venus. There were later experiments with balloons floating in the atmosphere. But that's a story for another day. So why haven't we returned? One simple reason is practicality. Venus is brutally hostile, and missions are expensive with limited returns. You can send a robot to Mars and have it operate for years. But the most durable Venera lander lasted only about 2 hours. The program ended just as the Soviet Union itself was dissolving, with leadership changes and shifting priorities. The 1990s were a tough period for Russian space exploration, and ironically, the march of technological progress may have worked against us. Older Soviet engineering emphasized robust, resilient machines built to survive extreme conditions, whereas modern technology, though far more capable, is often more fragile and harder to ruggedize for Venus Inferno. As one veteran NASA engineer put it about Voyager 1, its computer was essentially as powerful as a 1970s pocket calculator. Today, we carry far more computing power in an iPhone. But could you realistically launch an iPhone into space and have it survive 40 years of radiation, heat, and mechanical stress? Almost certainly not. The lesson here is clear. If humanity truly wants to push the boundaries of space exploration, we must learn from past successes. The ingenuity, durability, and sheer daring of missions like Venera offer invaluable lessons for designing spacecraft capable of surviving the most extreme worlds, even when the odds seem insurmountable.